Okay, in this video I'm going to begin exercise 6b of the book Fundamental Applied Mathematics. We're on page 162 and the question is 1. It reads: a projectile is fired from level ground at 20 meters per second. Find the speed of the projectile when it is 10 meters above the ground. Now the point of this is we're using basically the principle of conservation of energy, which is written there, saying the sum of the potential and kinetic energies at one time must be equal to the sum of potential and kinetic energies at another time in a gravitational field. This only holds if it's in a gravitational field. Alright? Then you have the work energy theorem, saying that the work is equal to the change in kinetic energy, delta Ke, and we know of course that U-grav, the potential energy in the gravitational field, is mgh, and the kinetic energy is 1/2 mv squared. So let's apply that. We're going to apply the principle of conservation of energy first of all. So we're going to find that the projectile is fired from level ground at 20 meters per second. So let's go for the kinetic energy. So it's a half times the mass. Okay, so I'm just going to call that m because we don't know it, times v squared, and that's going to be 20 squared plus the mass times gravity, and this is going to be, so let me think here now, the height is going to be equal to 0, is equal to a half m times the v squared, which we're trying to find, is equal to, not equal to, plus mg, and the height above ground we're told is 10 meters, like so. So let's just do a bit of cancelling here. We can get rid of m, get rid of this one altogether. So this becomes 200 is equal to v squared over 2 plus 10g. Okay, and that there is equal to, we'll say, 98. So if you work it out, you're going to get that v is equal to 14.28 meters per second, which is correct. That shows you, of course, that we're able to work out the velocities just using the work energy theorem or the principle of conservation of energy. Now, just to prove that we can do it using the projectile analysis, if we remember, of course, from accelerated linear motion that v squared is equal to u squared plus 2as, let's apply the same thing here. We're going to get v squared is equal to 20 squared, and then we're going to get plus 2 times negative 9.81 times distance, which is 10, and if you work that out, you're going to get v is equal to 14.28 again. Alright, so thanks for watching. Please pass it on to your friends and subscribe to my channel.